Well, hello there. How are ya? I am going to go over these problems and you're going to write them down. And it's so good to see. Well, I don't see you, but it's so good to know that you're listening and watching. Okay, so we're getting ready for the EOCs. Let me go ahead and tell you, you're amazing. You have been working hard, and there is no reason for you not to get a 5 on this EOC. So let's make this happen. Okay, the amount of medicine in Elizabeth's blood is modeled by the function m of t is equal to negative t squared plus nt, where t is the number of hours after she takes the medicine. How many hours after Elizabeth takes her medicine is the amount of medicine in her blood the highest? So let's go with a couple of things. The highest. This A is negative. When A is negative, that means that you have a sad parabola. So when it's asking for the highest, it's asking for the maximum, right? And that looks okay. And so they want to know when it's the highest at um, how many hours. So that represents our t. So in order to find the maximum, you need the vertex. And then specifically, we want the x of the vertex because x here is our input, which represents our hours t. So all we need to do is do negative b. X is equal to negative b over 2a. Okay, so negative b, this is b. The opposite of b is negative 10 over 2, and the a here is negative 1. So negative 10 over negative 2 is 5, everybody. Please understand this. We're going to go in great detail about these parabolas because these are the commonly missed problems all the time because we are not understanding what it's looking like. So if you understand that this is a sad parabola, it makes the n upside down, however you want to see it, negative means sad, that's you won't get this problem wrong. So the function f of x is equal to 1 half x minus 6 was replaced by f of x plus k is equal to 1 half x minus 4. What is the value of k? Well, if I'm adding k to f of x, all of this is f of x, right? So I'm saying 1 half x minus 6 plus some k gives me 1 half x minus 4. Okay? That's all it's really saying. Because this is f of x plus k. F of x plus k. And if you want to distribute this, it'll look like f of x plus f of k. So what is k? Well, k, everyone, has to be the y-intercept. Two ways to look at it. The y-intercept here is negative 6, so our b is negative 6. And over here, our b became negative 4. How does that happen mathematically? I added 2. K is 2. All right? Let's keep it moving. Please make sure you're listening and understanding the terminology so you won't get these problems wrong again. Surely graph the line shown in the coordinate plane. What is the x-coordinate of the point at which this line intersects the x-axis? So we're looking for this point right here. In case we can't estimate because it's filled in the blank, so we can't say, oh, it's between. We have to find the exact point. In order to do that, we need the equation of this line, right? And so we have 2 points, and so all we need is the slope and a point to find the equation of the line. So the slope is down 3 to the right 2. So m is equal to negative 3 halves. And then our point, we can use 1, 5. And then we do the 5-step rule. Label y equals mx plus b. Plug in 5 is equal to negative 3 halves times 1 plus b. 5 is equal to a negative 3 halves plus b. Add 3 halves to both sides. We'll get b is equal to 5 and 3 halves, or 13 halves, right? So they're looking for the x-intercept. And I'm running out of space, and it's probably you are too. So the x-intercept, this is the y-intercept. So our equation of our line is y is equal to negative 3 halves x plus 13 halves, correct? And so to find the x-intercept, let y be 0. y is 0. So we say 0. Remember, this is the order pair. The x-intercept is always y-intercept. Let's talk about y-intercept. Y-intercept is always 0 in a number. The x-intercept is always a number and 0. So your y is going to be 0. So y is equal to 0. Negative 3 halves x plus 13 halves. Subtract 13 halves on both sides. You get negative 13 halves is equal to negative 3 halves x. Multiply by the reciprocal. So I'm going to multiply by negative 2/3 times negative 13 halves is equal to x. I multiply by the reciprocal, and then these are cancel, and negative times negative is a positive, so you get x to be 13/3 or 4 1/3. And we know this is 4.33, repeating. I think I said round to the nearest hundred, something like that. That's how we do that, people. Okay, got to do the 5-step rule. After you find your b, let your y be 0, and then solve for x. That's your x-intercept. Next question. The table below shows the amount of money Bernard earned selling newspapers during a 6-week time period, which describes the relationship between the week X and the money Bernard earned Y. So, weak positive relationship, strong negative relationship, strong positive relationship. Well, as we can see, as the X's increase, the Y's, 110, 130, 130, and 70 there, 70 cents increase, 150. Y'all, this is a strong positive. Now, I think some people got confused that because the numbers are maybe not going up a lot. It's not about whether the numbers are going up a lot. They are going up. A weaker positive correlation will either have some things staying the same or have some negatives, which means one thing maybe from here to here it went down, and then the rest of them went up, and then maybe from here to here it went down. That may show a weak positive relationship, but there's no way for this to be a weak relationship that's positive because it's going up each time. Each time it's going up. So if it's going up each time, then there's a strong correlation, and it's a strong positive association or correlation. All right, next one. A quadrilateral has vertices, blah, 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 which best describes the figure. So some of y'all use the distance formula. I would tell y'all, please just graph it. Honestly, just graph it. Get some graphing paper and just graph this and just look at the figure. And if you can't figure it out, then find the distance between them. But y'all graph this problem. All right, so what do we know about a rhombus? A rhombus has all equal sides. So a square is a rhombus. What do we know about a square? Opposite sides are equal. Trapezoid has one pair of parallel sides. That's what them two L's mean, parallel sides. All right, -3. Hopefully I got enough. I don't. That's going to be wrong. I do -3, -5, like that. All right, so -3, 1, 2, 3, -5. Of course, you'll have graphing paper on yours a little better. 4, 2, 1, 2, 3, 4, 2, 4, 1. 2, -1. We know it ain't a square. I graphed this right. I feel like I didn't graph it right. Okay, -3. Let me check this again. -3, -5. -1, 2, 3, -5. 4, 2, 1, 2, 3, 4, 2, 4, 1. That's 4, 2. 4, 1, 4, 1, and 2, -1. All right, well, I can see. I don't know what the heck this is. We need to get some graphing paper. But we know it's not a rhombus, and we know it's not a rectangle. Gotta be a trapezoid. Goodness gracious. Let's just move on. All right, 24. Teacher surveyed 160 students to see how many students leave school during lunch. The results of the survey are shown here. And it says approximately what percent of boys surveyed leave school during lunch. Okay, so there's two ways to look at this problem. You can turn all these percents into actual numbers, and if you multiply 0.125 by these numbers, you'll get this table of boys that leave early. I guess I didn't have to do that. And then girls. So if you do that, you'll notice that there's 20 boys, 65 boys that stay in school, then there's 30, and then there's 45. So you can look at this like this. Out of the 20 boys that go to school, out of there are 20 boys that leave school out of the actual total of 85. So this is 85, this is 75. And you can add them together and get 160, make sure that works out. And then multiply that by 100, and we'll get around 24%. Or if you did not see it that way, some of y'all still do it the same way, so just do it with the percent. So if you add the percents up, if you add 0.125 plus 0.40625, you will get 0.53125, and then just put 0.125 over 0.53125, and again you'll get 24%. Okay, this question was a little weird. A liquid is evaporating. The amount of liquid remaining in liters after X weeks is modeled by the equation here. Approximately what percent of liquid evaporates per week? So this is what's remaining. And when you do this, everybody, you end up getting 0.47. I mean, no, 47.4552. Well, this is what's remaining. Actually, yeah, this is what's remaining. Okay, so we want to know how much is being evaporated. Well, this is out of 100, so we start off with 100. So we can look at these percent. So 47, about 47% is remaining. Therefore, 53% is evaporating. Y'all don't like the way I said that. Okay, so that's that. You had to think about this problem. This says what's remaining. This is actually what's evaporating. 53% of this solution is evaporating. All right, last two problems. I gotta hurry up. Last three. The function y equals 45x plus 6 can be used to determine the cost of a person purchasing X tickets to a concert. A person can purchase up to 8 tickets. What is the approximate domain for the function? All right, so if you can purchase up to 8 tickets, these are tickets. Tickets can't be negative. All right, so all integers are positive and negative numbers. That's wrong. All positive integers, well, that clearly works, less than or equal to 8. All positive real numbers include decimals and everything. You can't have a half of a ticket. That's wrong. That's why this is correct. All right, so using the line of best fit, what is the table of the data? What is the approximate predicted monthly expenses? Well, when you put this into your calculator, don't make a mistake, and I put 5 there the very first time Michaela brought this up, but you get A is to be 26.85, and then B is negative 4.82. And then when you write the equations, you get, this is what the calculator says, 26.85 x minus 4.82, and when you put 3 in here, you get 76. Okay? And the last one, which function can be used to determine the nth number in the sequence? Well, this is the first number, this is the second number, this is the third number, this is the fourth number. Okay? So it is clear that we're adding 2 each time. And so if you want to go back to the beginning, this is the first number. The 0 number would be 8. So a linear function will have, I'm adding 2 each time. That's the slope. Technically, that's the slope. This is my y-intercept, because this is linear. We're not multiplying. And therefore, we get y equals 2x plus 8, or y equals f of n equals 2n plus 8. All right, so I got to go. I got to hurry up. All right, it's been great. You've been amazing. Love you. Have a great time. Bye.